So all credit goes to these folks over here, especially Dr. Sanchez. He has developed most of this content, all of it. Okay. These are the people that I give credit to for the whole, you know. We're going to continue off of this. We're on the section. We're on the section over here. I believe we read up to, I don't remember, in analysis and flow, it's often convenient to do some to be as this. Alternate version, we showed how to do that. And then we already read this part. We were doing this part, the Gibbs equations. Gibbs equations. So Gibbs equations, the original form is shown by, I believe you just have to memorize it. I don't think there is a way for you to derive the Gibbs equation. I think it's just fundamentally just memorize, but um, if it's not, tell me. But uh, um, I think, yeah. So Gibbs equation is this. But this part we can derive, but I think this part you have to memorize, if I remember correctly. I don't think there's a way for you to figure that part out. Let me think. No, not to my knowledge. And I think it's the 16th time I've been using Gibbs equation because I don't know. Um, the reason I say that is because I think I wrote this equation down multiple times, different ways, earlier. So I think we both understand a little bit of it like this. Now we leave it in that form, especially now. And then what we do is the H equal E minus, I think it's minus right now, plus. It is plus, I'm wrong. Plus P over density. And we do DH equal DE plus DP over density. And we do a dot product. We do a particle here. E plus, basically we say D1 over density, and then plus 1 over density dP. And we see over here that we have this form. We can simplify saying dE equal, I believe it's DH minus D1 over density P minus dP over density. I mean, that goes to here. And we plug it back to here to get our final form. TdS equal, what was it called again? I don't remember. TdS equal, I believe it's I need to remember, DH, no, I did it wrong. I believe it's, no, I was right. dH plus, not plus, minus P d1 over density plus 1 over dP over density plus, no, this is minus, plus the same thing. So this cancels out with this, leaving us with T ds equal dH minus dP over density. And this is my understanding of how to get this form into that form. Simply doing, you know. Now the next section of it is doing what I call, I forgot what it's called. Uh, but it's simply just going from T ds equal dE plus P d1 over density. And then do ds equal dE divided by T plus P over T d1 over density, I believe. And what you have to do is realize ds equal dE equals CV dt, I believe. So CV dt divided by t. Now this is the problematic situation over here. Now, I don't. I need to realize that we can do the quotient rule. D1 over density. Quotient rule goes from low d rho. Is it rho? Yeah. D rho, and then top derivative is 0. Right now 1, and then we have rho squared. I believe this is another way to write that. And then what does that give me? This gives me P over T. Does this actually help me? D rho density. Not sure. I'm not sure if it helps me, but we will just write it. Um, Now this over here, we can kind of see. Do we want the density one? Yes, it looks like we do. So we want one of the density to be over here, so we move that out. P over rho equal RGT, right? And then we can move this T outwards to get to RG. So we can say the CV dt t equal plus rg d rho by rho is one of the forms, and that is number one. We checked off the Qing, so this one is done. And then now we have the other two. We have P dP over P RG, and then we have temperature here. I know how to get them. They're not impossible to get. They're not. impossible. This is how you get them, this form next. So what you have to do is realize TdS equals dH plus dP over density. And over here, you have to realize ds equal dH divided by T plus dP over rho, right? Rho, right? Yeah. So that's true. There's temperature here. And then what we do in this case is I believe we have to use dH equals Cp dt. So ds equals Cp dH t plus dP over density T. And then we have, because of this, we have, oh, this is dt. So we have it all. We just need to use ideal gas law, which says P over density equal RGT, and realize that we can do RG over P equal by 1 over rho T, and look at that, we have it. So Cp dt T plus RG and dP P. So that's the second one. Beautiful. QED. The last one is a little harder. Now, what we do is that these are equivalent expressions, right? So let's figure this out. They're equivalent expressions, so yeah, I don't know. This one, the last one, I don't know how to. Yeah. And do I want to spend